Whenever you see comparisons of MTF, you have to look at the presentation of the data. There are a number of ways that different companies express different MTF metrics. Hi, I'm Johnston and welcome to Ask an Expert. Today's topic is the subject of Modulation Transfer Function, or MTF. MTF represents resolution. High MTF, good resolution. Low MTF, poor resolution. Now, what are the elements of MTF? You have sensor MTF, how well the actual sensor can resolve light that hits it. You have lens MTF, the quality of your lens. You have system MTF, which is the combination of the sensor and the lens. You have electronics MTF, which is how the electronics process the signal and present it to the user. You have atmospheric MTF. You can see the camera shooting at long range across the river here, and it is going through the atmosphere, and the atmosphere presents optical aberrations that affect overall MTF. And then finally, you have display and eyeball MTF. The display that you use to look at the image has its MTF characteristics, and the eyeball has an MTF characteristics. That's why I wear glasses, because I have to improve the MTF of my eyeball. The important issue for us is sensor MTF and lens MTF. Those are the two most basic elements that we can optimize. There are a number of ways that different companies express different MTF metrics. The most important for a lens and a sensor combined with a field of view specified is cycles per milliradian. If you see line pairs per millimeter, that's something different. If you see cycles per pixel, that's something different. Those are different measurements, and they don't apply. They're unique to the specific situation that someone wants to relay, whether the lens is independent of the sensor or the sensor is independent of the lens. When you combine them together, you always need to understand MTF in cycles per milliradian. So we have two different cameras looking across the river at power transmission lines 6 kilometers away. The power transmission lines represent high spatial frequency content, meaning very fine detail in the stanchions of the tower and the thinness of the lines. That's another way of saying high spatial frequency. And the higher MTF image clearly gives you a better viewing of the 1-inch wide aluminum transmission lines that you can see strung from tower to tower. Whereas on the lower MTF system, you can see elements of blurring on these high spatial frequency features in that scene. The 1-inch aluminum lines are not as clear, and you can't see quite the detail on the towers. MTF is an incredibly complex subject. You hear us in the infrared world throwing out MTF this, MTF that. It's a complex subject, and we do our best with all the measurement tools we have in our lab to optimize MTF and accurately report MTF in a universal, meaningful way. This has been Ask an Expert. Thanks for watching.